Now we're going to look at or review kind of charge interactions and things that we talked about on the previous examples, and then how we can apply Newton's laws to this. So first off, charge interactions are forces. We know that if this tube is negative, that this paper will want to go to it if it's neutral. Okay, neutral and negative will have a force of attraction. Now, if we can get this distance exactly right, we can get the force of attraction, this electrical force, equal to the force of gravity. We could levitate this paper bit. And if you look on YouTube, you probably can see this. At some point, maybe I'll add that to this video. But right now, what I want you to see is that we can have balanced forces, and this object could be standing still by balancing electrical force, or the force of attraction between the negative and the neutral, and the force of gravity right here. So let's look at two like charged balloons. Okay, so we have two balloons, positive charge. They actually will repel, and so when they repel, what we see is the one positive goes this way, the other goes this way. Now, due to Newton's third law, these forces are equal but opposite, right? Newton's third law, equal and opposite reactive forces. So these forces are equal and opposite. So these will be, since the forces are equal, these things will be at equilibrium. They will not move. They will stay in this spot as long as no other forces act on them. Now, what this looks like in a free body diagram. Here is object A. You got your tension force at an angle. You got gravity and electrical force. So if this thing's standing still, we take the tension force and we break it into two parts. The y component of my tension force is equal to the force of gravity. Okay? And then the x component of my tension force is equal to the electrical force. Because it's not moving, all forces have to be balanced. And so that's what we expect to see. And for object B, same thing. I take my y component here of my tension force, that's equal to the force of gravity. And the x component of my tension force is equal to my my force of repulsion between the two objects. So if we know the force of tension and our angle, we can find what gravity and the other is. So I mean, there's a lot of different variables here that if we can figure them out, we can figure what the force of attraction or repulsion is.